Good morning, guys. Am I audible to all of you?
Yes, sir.
Good
Good
morning,
morning.
sir.
Yes, sir. Good morning, sir.
Morning.
Yeah,
My
good
screen,
morning, everything.
morning. My screen is also visible to all of you, right?
Yes, sir.
Okay.
Yes.
So in today and in our next session tomorrow, we are going to complete and we are trying to complete the multi-threading concept, right? Today we are going to discuss few important concept and the rest of the concept we are going to discuss tomorrow. And as of now, we have discussed multi-threading. We have created threads, and we have discussed many thread synchronization techniques like lock, monitor, semaphore, mutex, semaphore, slim. We have also discussed something called the thread pooling, right? And today we are going to discuss what are foreground and background threads, right? Then we will discuss the thread life cycle. We will discuss thread priorities, and we will discuss one application. I will show you the benchmark, performance benchmark between a single thread application and a multi-threaded application, right? I mean, what I'm going to do, I'm going to do a same, I'm going to do the same task using a single thread, comparing with a multi-thread application, right? Then I will come to the, then we will see which version of the application takes more time, whether single thread application takes more time or multi-thread application takes more time, right? So let's start today's session. Let us start with the discussion from the foreground and background threads, right? Suppose someone asks you this question: what are the different types of threads available in .NET framework? Or they might be asking what are the different types of threads that you can create in .NET framework. The answer is two types, right? Right? So two types means one is foreground thread and another is background thread, right? And whenever you create any application, right? Any .NET application, whenever you create it, right? By default, one thread is going to be provided by the CLR, or you can say by the operating system, and that thread is nothing but your main thread, right? From the main thread, only our program execution is going to start, and that thread is going to start our program execution by invoking which method? Can anybody tell me? Guys,
Main method.
main method, right? Because we know from our main method only the program execution is going to start, and from the which thread is going to invoke that main method? Main thread only, right? That is what we have already discussed. So let us discuss what are foreground thread and what are a background thread. What is the difference between them? How to create a foreground thread? How to create a background thread? Whenever we create a thread, by default it is a foreground thread, or by default it is a background thread. The main thread which will be provided by the operating system, whether that is a foreground thread or background thread. Let us discuss all these things. First, we need to understand what are foreground threads and what are background threads. Foreground threads are those threads that keep running even after the application exists or quits. So this is the point that you need to remember. Suppose you created one foreground thread, right? Suppose you create one foreground thread, and when your application exists or quit, still those foreground threads are running and they are going to complete their task. What it means? It means suppose your application start from the main method. The main method create one, two, or any number of foreground threads. And the main method execution complete, main method quit the application. Even though main thread quits the application, the foreground threads what you are created in your application for your application, they are still running. They are going to complete their task. Once they complete their task, then only they will quit. As long as the task is not completed, foreground threads are running, even though your main thread or the main application quits. If still not understanding what is this, we'll understand this with an example, right? So the foreground threads do not care whether the main thread is alive or not, whether the main thread, right, which is running your application, whether that thread is running or that thread completes their task, it doesn't matter. Foreground thread means it will definitely complete its task. Whatever task you are assigned to the thread, you are assigned to the foreground thread, that task 100% going to be completed even the main thread completes its task. So that means the life of a foreground thread in C# does not depend upon the main thread. Whether your main thread completed or not, right? That doesn't matter. Foreground thread means 100% it is going to be completed. Then what are background thread? Just opposite of foreground threads. What it means? Background threads are those threads that will quit if our main application quits. If you compare this definition with the previous one, foreground threads are those threads that keep running even after the main application exists or quits. Background thread are those threads that will quit if our main application quits. Suppose you created a one background thread and your main application is running by the main thread, right? And when the main thread completes the task, it doesn't matter whether the background thread complete its task or not. As soon as the main thread completes, the background thread is also going to be, I mean, stop, right? Whether the task is completely performed or not, that doesn't matter. Main thread stop, main thread quits means background thread automatically going to be quits, right? So in simple words, we can say that the life of the background threads will depend on the life of the main thread only. As long as main thread is run, as long as the main thread is alive, the background thread is alive. As soon as the main thread quits the application, the background thread automatically quits the application, right? Background threads are viewed by CLR, and if all foreground threads are terminated, then all the background threads are automatically stopped. Suppose in your application, you have created four foreground threads and you have created two background threads. One of the background thread execution completed, another background thread is still executing. At the same time, all the four foreground threads that you have created for your application, all threads, they have completed their task. So they will quit the application. As soon as all the foreground thread quits the application, the background thread which is running, that will also automatically stop and quits the application. And by default, whenever we created a thread instance by using the thread class, it is going to be a foreground thread, right? So guys, you understand what is the difference between background and foreground threads?
Yes.
So in simple one, background thread means once the main thread quits, it is going to be quit. Foreground thread means once the main application and main thread quits, the foreground thread still executing to complete its task. As soon as the task is not completed, foreground threads are going to be run, right? They are running. But in the case of a background, main application or main thread quits means all the foreground threads quits means the background threads are automatically going to be quit. Then how to make a thread as a background? So if by default, whenever you create a application, right? Suppose you created a thread by using the thread class, then by default, the thread is going to be a foreground thread. Then the question is how we can make a thread as a background thread. Now, if you go to the thread class, right? If you go to the thread class, then you will see there is a property called each background. So there is a property called each background, and you can say it's having both getter and setter. Yes or no?
Yes.
Right. So this is a property, right, which is having both get and set accessor. And which type of a property is this?
Boolean.
Boolean type. That means if you set the property to true, suppose each background is one property, and if you set this property to true, then that is going to be a background thread. And if you are not setting any value, then by default this is going to be false. And if you explicitly set the value as false, then it is going to be a foreground thread. See, get or sets a value indicating whether or not a thread is a background thread. True if this thread is or is to become a background thread, else false. That means if you set this property to true, then it is going to be a background thread. And if you set this property to false, then it is going to be a foreground thread. Then how you can set? See, it's very simple. Say it's a property of the thread class, and we know how to set. So first of all, it is a static property or non-static property. It's a static or non-static?
Non-static.
Non-static means if you want to set, that means first of all you need to create an instance of this thread class. Once you create the instance, then only you can set the value. Suppose I am creating one void method, static void main, static void. I'm creating some method, right? And within this some method, I'm passing this one to this class. See, once you pass, then you can access, right? Thread dot, there is a each background property, right? And you can set this value to true. And you can also, so at this point, this thread is a background thread, right? And if you are not setting this property to false, right, then it is going to be a foreground thread, right? Even while you are creating the instance, you can also set the property value is background equals to whatever value you want, you can set, right? So this is how you can set the property. And if you want to get the property, simply how what you can do is you can just write console dot write line, right? And you can access the property also. Thread dot is background. So as it is a property which is having both setter and get accessor, so you can set the property like this by assigning some value, and the value should be of a Boolean type because the property is of type bool, right? And then you can also access the value by using this one. So in this case, the set accessor is going to use, right? In this case, the get accessory is going to be used. So how you can set the value, how you can make a thread as a background thread means by using this each background property, and you can set this property value to true. Is that clear, guys? Clear or not?
Yes, it's clear.
Okay. So now let us first see one example of a foreground thread, and then we will see one example of a background thread, right? So in this case, so by default, the main thread is going to execute your application. So which thread? Main thread is going to execute your application code. Main thread started here. One child thread is created. Do I have set the each background property?
No.
No,
No. Then by default, whether it is a foreground thread or background thread,
background.
Foreground.
if you are not setting the value, the default value of a Boolean data type is false, right?
Default is false. It's a foreground.
So false means it's a background or foreground. It's a foreground thread. So in this case, you can see I'm accessing the each background property, and this is going to return me false value, right? False means it's a foreground thread. Then I'm starting the thread, and then my main application completed, right? Even though your main application quit here, as this is a foreground thread, you will see that this thread is this method is still executing, and it is going to complete its execution. So here method one will start, here method one will continue, and it will wait. So you can see main method execution is completed. Even the main thread execution is completed, as this is a foreground thread, this execution, this method execution is going to be complete at any cost. The thread is not going to be quit as long as your main thread quit the application, right? Let's see. See, main thread executed, but even the main thread executed, say the foreground thread is still executing in or not, the foreground thread completed its task or not. Here main thread completed its execution. After main thread completed its execution, the foreground thread is also going to complete its execution or not. Is the foreground thread quit as soon as the main thread quit the application? No.
No, it's still running.
So it's still running, and it is going to complete the application. Now what I'm trying to do is I'm making this thread as a background thread. How to make this thread as background thread? So how I can make? So there is a property called is background, and I just need to make this property as true. As soon as I make this property as true, you will see that this is background property is going to be true. And as it is a background thread, you will see that once the main thread complete its execution, immediately this statement is going to be, immediately your application is going to be quit. You cannot see these things, right? Let me run this. See, you can see, am I able to see the output screen? Guys? Why I'm not able to see the output screen? Can anybody tell me? Because as soon as this statement is executed, it will quit the application, right? Now, so let me modify the example in a different way, right? So what I'm trying to do is I'm calling the thread, right? I'm making the thread to sleep for 2000 milliseconds. But this statement, this method is going to take more time, right? This loop is going to execute for 10 times. Each time this loop execute, thread will sleep for 100 seconds, right? In this case, I'm using this thread class sleep method. So it will halt the main thread for 2 seconds. After then, it will come and exit from the application, right? Now you can see the output, but after some time, see main thread is started, it is executing. But once this thread sleep completed 2000 milliseconds, the thread will wake up and the thread will exit the main application. So here you can see, as soon as your main application quit, the other thread which is running in the background, that is the background thread, is also quit the application, right? But in this case, if I make this as false, right? So by default it is false. If you make it is as false, then you will see that even though your main thread complete, main thread exited, the other thread, which is a foreground thread, is still executing, and that foreground thread is going to complete its task at any cost. Understand what is the difference between background thread and foreground thread?
Yep.
Okay. Right. So now let us see another example. Right? Another example means what? Okay, let me write the code. So here, the main thread is a foreground thread or background thread? Main thread is a foreground or background?
Foreground.
Foreground. So this thread, what we have created, right? Thread 1, it is a foreground or background?
Foreground.
This thread 1 is also a foreground thread, right? So this main thread creating this foreground thread will start here, right? The foreground thread will invoke which method? Method 1. That means your program execution will start this. As it is a foreground thread, until and unless whether your main thread quits the application, but still this method is going to complete its execution or not?
Yes.
Yes. And as part of this method, I'm creating another thread. So this thread 2, it is a background thread or foreground thread?
Background.
Why? Because we have made this is a background property to true. And this is a background thread, and this thread calling which method?
Method 2.
And in this method, you can see I'm using a loop which will execute for 10 times. Each time the loop will execute, it will sleep for 1 second, right? And that means once your method 1 execution completed, and once your main thread execution completed, right? Not only this main thread, which is a foreground thread, so the background thread are going to be quit when all the foreground thread completes their execution, right? All the foreground thread means what? Now this is one foreground thread, main thread. This is also another foreground thread, that is thread 1. So when main thread and thread 1 complete their execution, then only this background thread quits the application automatically. Is that clear? Guys?
Yes.
Yes.
Right? So that means in this example, we are having two background threads. So, sorry, we are having two foreground threads. Once all the foreground thread completed, then the background thread is also going to be completed automatically. Method 1 exited, right? Method 1 exited. Then you can see it is waiting for me to give some input, right? As soon as I press the button, you will see that it is quick. Right? So it is quitting the application. So this is the point that you need to remember. Right? Clear or not? So the point that you need to remember is once all the foreground thread, including the main thread, quits the application, then automatically all the background thread quits the application. Clear or not? This point.
Clear.
Okay. Some points to remember. In C#, a thread is either a background thread or a foreground thread. Background thread are similar to the foreground thread, except that the background thread do not prevent a process from terminating, right? If you are using a background thread, then it will not prevent the application to terminate. It is the application is going to be terminated, right? Once all the foreground thread belonging to a process have terminated, then the CLR end the process. Any remaining background threads are stopped and not completed, right? By default, the following threads execute in the foreground, right? The primary thread, the main thread, it is a foreground thread. All the threads that are created by calling the thread class constructor, right? By default, they are foreground thread. And if you use the each background property, then that is going to be a background thread. And by default, the following threads are executed in the background, right? If you are using thread pooling concept, then by default, the thread are going to be background thread. Clear or still doubt? Guys, this concept is clear. What is exactly background and foreground threads? Shall we proceed for the next concept?
Next.
Okay. Okay. The next important topic that what we are going to discuss is thread life cycle. From the beginning, I am saying thread life cycle, thread life cycle. So what is thread life cycle? And whenever we are saying the life cycle, you know what exactly it means. Suppose if I'm asking what is your life cycle, what is my life cycle? My life cycle means what? When I born and when I end. In between that period, what I'm doing is nothing but my is going to be my life cycle, right? So in the same thing, a thread also has a life cycle. So which will start, the thread life cycle will start when we create an instance of the thread class, right? When you create an instance of the thread class, that thread life cycle will start and ends when the task of the thread is completed, right? That you are creating the thread for to execute a task, right? To execute one method, right? So when you create the instance, the thread life cycle will start. And when the task that thread performing is completed, then the life cycle is end. Even though you can also terminate a thread, right? Terminate a thread means when you call the abort method on the thread instance, that thread is terminated, and when the thread is terminated, then also its life cycle ends. So the thread life cycle will start by creating an instance of the thread class. The thread life cycle is completed or end in two ways. In the normal way, by completing its execution, by completing the task, and in other way, by calling the abort method. Abort method means the thread execution is going to be aborted, right? So in this two way, we can terminate a thread, right? By default, automatically execution completed means thread completed, or you can complete by, or you can terminate the thread by calling the abort method, right? So in our next session, we are going to discuss one important concept, how to terminate a thread in .NET framework, right? So life cycle means from the beginning to the end, what are the different steps a thread can go. That is nothing but the life cycle of a thread. So a thread in C# at any point of time exists in any of the following states, right? What are the state? On stated, a runnable state, a running state, not runnable state, and dead state, right? So why I'm not discussing this thread life cycle from the beginning, and why I'm putting this at the end? Because to understand this thing, you need to understand some concept, right? And those concepts we have already discussed. So now it is time to understand the thread life cycle, right? So what is the life cycle of a thread means? Whenever you create an instance of the thread class, the thread life cycle starts. So in this case, you can see here I'm creating an instance, right? Here you can see I'm creating an thread class instance. So here I'm creating the thread class instance means the thread is started, right? The thread life cycle started. And when you create an instance of a thread class, the state is going to be on started state, right? There is a property called a thread state, right? If you go to the thread class, there is a property called a thread state. You can see this is the property thread state, and this thread state property returns an enum, right? And that enum is going to store, is going to return the current state of the thread, and you can see there is a state called on started, right? So by default, whenever you create an instance of the thread class, right? Okay, so let me prove this one also, right? So let me remove all these things. Console.read key, right? So what I'm trying to do, thread state, right? So this thread is created, but I have not done anything else. So when the thread is created and when I call this thread state property, then you will see that, okay, let me remove all these things. I don't require these things. So in this case, you will see that this thread state is going to return me a state indicating the current state of the thread. And in this case, the state is going to be on started. On started means you just created the thread and you have not called the run, you have not called the start method. Just the thread instance is created, the state of the thread is on started. And in this case, this thread is not alive, right? In this case, the thread is not alive, right? How you can check whether a thread is alive or not? The thread, and there is a property called is alive, right? If you go to the thread class, then you will see there is a property called is alive. It will indicate whether the thread is alive or not. And at this point, the thread is not started, it is just created. So the state is unstarted, and unstarted means the thread is not yet live. It's not alive, right? So you can see this property is going to return me false. So what is the use of a thread start? It is going to return me the current state of the thread. What is the use of a is alive property? It is going to return me whether the thread is in running state or not. If the thread is not running, if the thread is not started, then this property is going to return me false. So by default, whenever you create one thread, right, and if you have not called the start method, then the state of the thread is unstarted. Clear what is the state is?
Yeah.
Right?
Yeah.
Okay. Okay. From this unstarted state, the thread can enter into the runnable state. From the unstarted state, the thread can enter into the runnable state, right? So what is the difference between this runnable state and running state? Suppose I have created one thread. Suppose I'm creating a for each loop. I'm creating a for loop which is going to run for 10 times, right? And in this 10 times, what I'm doing, so when the thread is created, the state is unstarted. And after this, what I'm doing, I'm calling the start method, right? So what I'm trying to make you understand is what is the difference between, right, this running state and runnable state. So you can see there are two things, runnable state and running state. So you just tell me, if I call the start method, do you think that this method immediately going to be executed? Or it is going to be there in the queue, and from the queue thread scheduler will decide any of the thread to be executed. If there are 10, so if I'm executing this for loop 10 times, that means 10 threads are going to be created in the ready queue. Do you think that all the 10 threads are going to be executed at the same time? No. All the threads are not going to be executed at the same time. So at that time, what will happen? The thread scheduler will pick one of the thread, and that thread is going to be execute your application code. Yes or no? Guys,
Yes, sir.
right? Do you think that if I'm executing this loop 10 times, all the 10 threads are going to start execution immediately? No, they are not going to start the execution immediately. So it's basically depend upon the logical processor on your machine, right? Suppose your machine having a single processor, right? Single one core is only there, then only one thread can execute this method, right? If your machine having two core, right, then two threads can execute this code at the same time, right? If your machine having four core means four thread can execute this code at the same time, right? If your machine having 8 logical processor means 8 thread can simultaneously execute this application code, right? In my machine, you can see if you go to the performance CPU, my logical number of a logical processor is 8. That means 8 threads can simultaneously execute this application code, right? So in this case, let's assume that you have a two-core processor. Two-core processor means two threads can simultaneously execute your application code, right? But in this case, I'm creating 10 different threads, right? Then 10 threads means 10 threads are going to be there in the waiting queue, right? Or you can say ready queue. Okay, from the ready queue, thread scheduler will pick two threads, and those two threads is going to be execute your application code. And rest 8 threads are there in the waiting queue. And once any of the thread going in the sleep mode, right, or any of the thread which is executing the current method, right, taking more time, right, or if any of the thread what CPU allocate time for that method, if that method not completed the execution, then that will be again come into the ready queue, right? From the ready queue, other thread which are there, the scheduler will pick one of the thread, and that thread is going to be execute the application code. That means here two things you need to remember. As soon as you as soon as you call the start method, it is not going to be executed immediately. It is going to be there into the ready queue, right? From the ready queue, the scheduler will pick one of the thread, right? And that thread is going to be executed. Clear or not? Guys?
Yes.
Right? So what exactly it means? It means when this unstarted state means the thread is just created. A runnable state means what? Now you just call the start method on the thread instance. When you call the start method on the thread object, the state is changed to runnable state, or you can say ready to run state, right? This runnable state, give me 1 minute. Right? So in this case, this runnable state means you just call the start method. The thread is there in the ready queue waiting for to be executed by the waiting for to be picked by the thread scheduler, or you can say ready to run state, right? Once you call the start method, now the thread is ready to run. But when the thread is going to be run, that will be decided by the operating system or thread scheduler, right? There are might be scenario, there are multiple threads are there in the ready to run or runnable state. Out of all the threads, scheduler will pick the threads and the thread will going to be executed, right? So runnable state is simply, you can speak, you can say that when we call the start method, the thread will move from unstated state to runnable state. Runnable state, right? Runnable state means ready to run state. Now the thread is ready to run. Then the thread scheduler will pick the thread and will run the thread, right? From this state, right, the scheduler will decide what to do. So from this state, only one thing is possible: the thread going to be execute, right? And suppose the scheduler will pick one of the thread and start executing the method, then the state of that thread is going to be changed to running state. So unstarted means thread created. Runnable state means when you call the start method, the state change to ready to run or runnable state, right? From this runnable state, if the scheduler pick the thread and start executing the application code, then the state is going to be changed to running state. Running state means when the thread executing your application code, at that time you can say that the state is running state. Clear? A runnable state. What is runnable state? Guys?
Yes.
Yes.
And from this runnable state, when the actual execution start, right? When the method, when the thread actually executing your application code, at that time the state is changed to running state, right? From the running state, you can see it can move to not runnable state. From the running state, it can again come back to the runnable state. From the running state, it can go to the dead state. So these three things we need to understand. What is this not runnable state, what is this dead state, and how it come from running state to runnable state, right? So suppose your method execution going on and the method execution completed. Once the thread complete its execution, right, then the state of the thread will be changed to dead state. Understand? Once your suppose the thread executing your application code and the thread complete its execution. Once the thread completes its execution, the state of the thread will be converted to dead state. Or if your application is running and if you abort the code, right? If you abort the thread by calling the abort method, there is a method called abort, right? So if you go to the thread class, then you will see one method called abort. There should be one method called abort. Where is that method? Yeah, you can see abort method. So when you call this abort method, the execution is terminate. The thread execution is terminate, right? So once the method execution completed successfully, the state will be changed to dead state. And when you call the abort method, then also the state is changed to dead state, or you can say aborted state. So from the running state, if method execution completed successfully, it will come to this state, right? And if the method execution aborted, then it will come to this state. From the running state, the thread can also go to the not runnable state, right? So not runnable state means what? Now, when a thread finds itself in any of the below situation, then the thread will move into the not runnable state, right? And the thread is no longer eligible to run, but in this state, the thread is still considered to be alive, right? Suppose in this case, suppose you are in the running state. Okay, from the running state, you call the wait method, or you call the sleep method, or you call the join method. We have already discussed wait method. We have discussed in our mutex and mutex class. Wait method means the thread is suspended for some time and wait for a signal from the other thread, right? When you call the join method, so we already discussed when we call the join method, right? Yeah. So suppose in this case, right? In this case, right? Suppose I call this thread 1 start, and I call this thread 1 dot join method. So, right. So if I call this thread 1 dot join method, then the main thread is suspended for some time or not? The main thread is in the not. So in this case, the main thread is in not runnable state. And how long is the thread is going to be in not runnable state? As long as the thread 1 complete its execution. But from not runnable state, it cannot directly come to the running state. From there might be scenarios. In this case, it's a main thread, right? Right, there might be some scenario. There are multiple threads, right? They are in the waiting queue, right? So from the not runnable state, the thread will move into the runnable state. From the runnable state, only it will come to the running state. Suppose you call this a thread dot sleep method, right? Suppose here you call this a thread dot sleep method, right? Here you call this a thread dot, okay, not thread dot sleep method for some time. So in this case, this thread 1, which is executing your application code, will sleep for 1000 milliseconds. So when you call this sleep method, the thread will move from running state to the not runnable state, right? This from this state, the thread will move to the not runnable state. From not runnable state, it will again go to the runnable state, because from the runnable state only the scheduler will pick the thread and execute the code, right? Suppose you are calling, see, I'm not going to show that example right now. You know how to create mutex object, right? And how to call the wait method, right? If you are calling the wait method, then again, the thread will move from running state to the not runnable state, right? So this is what you need to understand. And the dead state means when the thread complete its task, then it will enter into the dead state, or when you call the abort method, then again it will enter into the dead state. But the point is that once the thread completes its execution, right? For example, you are writing this statement, right? You are writing this statement thread one dot start, right? And once you write this thread one dot abort method, means the thread will terminate. And once you terminate the thread, then you cannot call this start method. You cannot call this start method because the thread is already terminated. On a terminated thread, or you can say a dead thread, you cannot again call the start method, right? So these are the different states of a thread. Unstarted means thread is just created. Runnable state means the thread is ready to run. That means when you call the start method, it will move to runnable state. From the runnable state, when the scheduler pick the thread and start executing the application code, it is the state is moved changed to running state, right? From the running state, the thread can move to not runnable state, right? Or directly it will return to runnable state, or it will move to dead state, right? So if the thread execution completed, then it will move to the dead state, or when you call the abort method, the thread execution terminated, and again it will move to the dead state. And if you are calling the wait method, sleep method, or join method, right, then the thread will move to the not runnable state, and from the not runnable state, it will not directly come to the running state. It will go to the runnable state. From the runnable state, the scheduler will pick the thread and will start re-executing the application code. The point that you need to remember is when the thread state is unstarted and when the thread is dead, right? When it completes its execution, then the each elif property is going to return us false. And the state like runnable state, running state, and not runnable state, in these three scenarios, the each elif property is going to return us true, because in this case, the thread is not completed its task. The thread is elif. It's going to complete this task, right? Once the task execution completed, and once the start execution not started, or you have not made the thread to be ready to be run, then in that case, the each elif property is going to return us false. Is that clear?
I have a question, please.
Yeah, tell me.
Will you go to the image, please? Okay. In what cases it will go back and forth between runnable and running?
Simply
You have
suppose,
arrows
suppose
back and forth between
yeah.
running,
So
right?
see, suppose your application, the thread is running, right? From the running state, you just call the suspend method, right? When you call the suspend method, then it will move to the runnable state, and when you call the resume method, then again it will move from runnable to running state, right? You can call the start method, which is moved to runnable state. Again, you can suspend the thread execution by calling the suspend method, and from the suspend method, again you can resume the method execution by calling the resume method, right? That what I'm going to discuss in a bit, but here you have a chance to suspend the method execution. You are not calling the wait, sleep, and join. You are just suspending the method thread execution for some time. At that time, you can suspend the execution. In that case, it will come to the runnable state, right? Suspend, and when you call the resume method, from this state, it will go to the runnable state. From the runnable state, the thread will come into this state, right? So you can see there are some method called suspend and resume, right? So you can see there are a few properties of a thread class. We have already discussed this current thread property, what it is going to return. The current executing thread instance, it is going to return each elif. It will indicate whether the thread is still alive or not. Name means what is the name of the thread, and thread state means what is the current state of the thread. That is what it is going to return. Sleep method we have already discussed. It will make the thread to sleep for some amount of time. Join method means it will block the current thread until the thread on which the method is invoked complete its execution. Abort method means it will terminate the method execution by throwing one exception called the thread abort exception. Suspend method, this method means it will suspend the thread execution for some time, right? And resume method means it will again continue its execution, right? And start method, we have already discussed what is the use of a start method. Means the thread execution is going to be start only when you invoke the start method. Immediately it is not going to start its execution, but it is ready to be executed by the thread scheduler, right? Sometimes the method start execution immediately, sometimes it is going to be there for a longer period of time in the waiting queue, right? Now what I'm trying to do is I'm going to create one application and I'm going to show you the different state of the thread so that you will understand this concept very clearly, right? So in this case, I'm just creating, suppose I'm having one method and this method is doing nothing. Suppose this method is having a simple for loop, right? Inside the for loop, we are just making the thread to sleep for 1000 seconds. That means this for loop will execute 3 times, means 3 seconds this method is going to be sleep, and up to then this method is going to print this statement, some method is completed, right? In this case, I'm just creating the thread. So in this case, I'm just creating the thread. That means before calling the start method, right? Before calling the start method. So you just tell me what this is elif property is going to return me. It is going to return me true or false.
False.
And what this thread state is going to return me?
Not started.
Unstarted, right?
Not started.
So when I'm calling the start method, right? So I'm calling the start method means what this each elif property is going to return me? True or false? So as I have told you, right? When the thread is in unstarted and dead state, in these two states, each elif property is going to return me false. In any other state, it is going to return me true. So in this case, when I call the start method, so what should be the each elif property? It is going to be true or false? True. And what is this state? It is going to return me running state, right? And in this case, I'm suspending the method. So in this case, it is going to return me suspended state, right? And is elif is going to true. Resume means again running state. So once I call this resume, it is going to return me running state, and the state is going to be is elif, right? In this case, I'm uprooting the application execution, right? Thread.abort, right? Once I call this thread.abort, so is elif is going to return me what? It is not going to return me immediately true, because once you call the abort method, right, then it is going to terminate the thread, right? For terminating the thread, it will take some time, and immediately you are printing this value means it is going to return me true, and then it is going to return me the thread state that is aborted, right? Once you terminate the thread, again, if you want to start the thread execution, in that time, it is going to throw me one exception, and that exception message I'm printing here, right? Let me run the application and show you the different state of a thread, right? So you can see before start is elif is false, thread state is unstarted. After start is elif true, thread state is running. After suspend is elif is true, thread state is suspend requested. Requested means you are just requesting. And when you call the resume method, right, when you suspended and when you call the resume method, it will again go to the runnable state. From the runnable state, it will come back to the running state, right? You cannot see this runnable state, but this state is there in behind the scene, right? So you can see runnable running state. And when you call the abort method, you can see still it is showing me the status as true, because the request is abort. You are just making a request to abort the thread execution. Immediately the thread is not going to be aborted. The process will take some time, right? Whether that thread is running or not. All these things are going to be checked behind the scene, and then he will abort the request. And then on the aborted thread, if you are calling the start method, then you are going to get this error. What is thread is running or terminated, it cannot restart. So in this case, you have terminated the thread, right, by calling the abort method, so you cannot restart. Right now, what I'm going to do is, I just want to show you the dead state, right? So what I'm going to do is, instead of calling this abort method, right, I'm just calling thread1.join, right? Thread1.join. So once I call thread1.join, right, it will block the main thread. It will first complete, the thread one will complete its task. After the thread one complete its task, then this statement is going to be executed. Once the thread complete its task, then the thread will move to which state? Guys,
Dead state.
right? And in dead state, what this property should return me?
False.
Okay, let's see this thing. Right? So you can see the sum method completed. Completed means what? The execution of thread is completed. After the execution completed, so this message is wrong. Here I am writing abort, but forget about this statement. What is this? Is elif property is returning?
False.
False.
And thread state is stopped because the thread execution is completed. And once the thread is completed means it is a dead thread. On the dead thread, you cannot call this start method. Any question from anyone related to this bigger picture? Any question from anyone?
It's okay.
Okay.
That's
Okay. Yeah. The next important topic, what we are going to discuss is thread priorities, right? So from the beginning, we are saying thread priority, but what is exactly thread priority and why I'm not taking this thread priority seriously? That is what we are going to discuss now, right? So let us first read these two paragraphs so that you will get some better idea. Why I'm not taking this thread priority seriously. In C#, every thread has a priority that determines how often the thread gets access to the CPU time, right? How often the thread accessed by the CPU, that basically depends by the thread priority. In general, a low priority thread will get less CPU time than a high priority thread. That means if the priority of the thread is less, then it will get less CPU time comparing with a high priority thread. If the priority of a thread is high, then that thread will get more CPU time comparing with the low priority thread. Guys, give me 1 minute. So the first point is what is the use of a priority means? Priority will decide how much time the CPU is going to give the time to that thread. If you are setting a high priority means the CPU will give more time to that thread comparing with a low priority thread. But this is the most important point that you need to remember, right? The most important point that you need to understand is how much CPU time a thread will get. It does not only depend on its priority, but also depends on the kind of operation it is performing. If you are setting the thread priority as high, don't think that the CPU will give more time to that thread, right? But apart from this thread priority, other things also takes into consideration by the operating system, right? What is these other things? Let us understand. For example, if a high priority thread is waiting for some shared IO resources to complete its task, then it will be blocked and taken up by the CPU. At the same time, a lower priority thread may get the CPU time and finish its execution if it doesn't require such IO resources. Let's assume that you have two threads. One thread is a high priority thread, and another, suppose, let's say thread 1 is a high priority thread, and the thread 2 is a low priority thread. The difference is that the thread 1, which is a high priority thread, it requires some IO resources, input, output device resources, right, to perform or to complete its task. Or it might be possible that that thread is doing some database kind of operations, or that thread is calling some external API to get the resources, right, to get the data, right. But the thread 2, which doesn't require such IO devices, right, that low priority thread doesn't making any API call, or that low priority thread is not invoking any database kind of operation. It is not performing any kind of a database operation. Then in that case, as the high priority thread going to call some third party APIs, or it is waiting for some IO resources to complete its task, then in that time, the CPU will not give more time to the high priority thread, right? So what he will do, he will give time to the low priority thread, and the low priority thread will come fast and will complete its execution, right? So in this case, a high priority thread may get less CPU time than a low priority thread over a specific period of time, right? So that means what? If in situations like this, right, in situations like this, a high priority thread may get some less time as compared to a low priority thread over a specific period of time. Not for all always, but sometimes. Sometimes if the thread is there to do some database kind of operation, or to do some API operation, or require some IO devices which is not available at that time, then in that scenario, it is going to give the more time to the low priority thread, so that the low priority thread will complete its task, right? Another factor that determines how much CPU time is allocated to a thread is how the task scheduling is implemented by the operating system. You know what happened whenever we are creating multiple threads. Let's say we have created 2 high priority thread, 2 medium priority thread, 2 low priority threads. So 6 threads are there in the ready queue, right? But who is going to pick the thread and start execution? Thread scheduling, or you can say task scheduler, or you can say task scheduling, right? Task scheduling or thread scheduler will pick one of the thread from the ready queue and will execute the task. How the task scheduling is implemented by the operating system, that also basically decide who is going to get more time, whether the high priority thread or whether the low priority thread. So simply speaking, if you are setting the priority of a thread, right, it will not give you guarantee that the thread is going to be executed fast, is going to be preferred fast by the operating system, right? So in some scenario, right, because the operating system doesn't care whether you set the priority as a thread, or whether you are setting the high priority or low priority, right? Operating system will pick the thread as per its implementation. Yes, sometimes it is respect the high priority and the low priority, but I never find this thing is useful in any of my application, right? So if you are setting the high priority, low priority, sometimes you will see that high priority thread will execute fast. Sometimes you will see that the low priority thread will also execute fast. That means what? That means if you are setting the priority, it is just for our internal satisfaction that we are setting the high priority, this thread is going to be executed fast. But that is not true. That is not true always, right? So apart from that priority, the other things are also going to come into the picture, right? Other things like how the task scheduler is implemented, whether the thread is taking more time to complete its execution, whether the thread requires some IO resources, right? All these things are come into the picture while the thread is going to be executed by the scheduler, right? So simply speaking, it doesn't give you guarantee if you set the priorities of a thread that the thread is going to be executed fast or fast. Yes, let's see and let's prove this point, right? So and how to set the thread priority means, if you go to the thread class, then you will see that there is a property called the thread priority.
So there should be a property called the thread priority name thread state managed. Yeah, you can see thread. This is the priority, and you can see this priority. It's a property and it's a get and set accessor, means you can set the priority of a thread by using this priority property, and you can also get the priority of a thread by using this get accessor, right? And what value you can set with this priority properties is nothing but this enum. So it's going to be enum, and you can see how many priorities are there. Lowest priority, below normal, normal, above normal, and highest priority, right? If you are setting the priority value as lowest, it is having the lowest priority. If you are setting this value highest, that means it is the highest priority. And by default, when we created a thread, it is set with the default priority, that is normal, right? And you can see above normal and below normal. Is there any question related to this priority enum? Guys, guys,
Yes.
No question.
okay. So this is a simple priority enum. It's having this value, and you can set and get the value the same way you are setting the each background property, right? In the same way you can set the priority. How you can set the priority? Let's see. Okay, suppose you want to set, so there is a property called a priority, and this priority is nothing but a thread priority dot enum. Enum means whatever want you can set, right? Normal, highest, lowest, whatever value you want, you can set. And if you want to get the priority, simply you need to call this method, right? How thread dot priority, right? So this is how you can set and get the priority of a thread, right? So these are the different values that you can say: lowest, below normal, normal, above normal, and a highest, right? And how to set and get the priority of a thread we have seen. Let us see one example for better clarity, right? See, in this case, what I'm trying to do is I'm creating 3 threads. One is thread 1, and the priority of this thread is normal, right? You can set like this, and even if you want, you can also set the priority inside this constructor, right? That is also fine. Then you can say I'm setting this priority as normal. I'm setting the thread 2 priority as lowest, and I'm setting thread 3 priority as highest. And whatever priority I'm setting, I'm getting the priority value, right? Then I'm calling the 3 threads, right? And then I'm making this console.read line so that I can see the output, right? So in this case, you can see each method, each thread is going to call this sum method, right? And in this case, what I'm doing, I'm just using a for loop to execute the loop 3 times, and in 3 times, I'm just printing the I value, right? And the thread which is executing, that thread name I'm printing here. So in this case, what is your assumption? According to the implementation, you might be thinking that the thread 3, which is set as the highest priority, should execute first. The thread 1, which is set as the normal priority, should execute second. And the thread 2, which we set as the lowest priority, should execute as the last thread in this example. That is what your thought process, or anything else you are thinking, guys? So
Yes,
according to your understanding, according to the thread priority concept, you are setting thread 3 as the highest priority. You are setting thread 2 as the lowest priority. You are setting thread 1 is the normal priority. So according to this is the highest priority. So CPU should give more time to this thread comparing to this normal. So normal priority should get more time comparing to the lowest priority. So you might be thinking that in this case, thread 3 will execute first, then thread 1 will execute, then thread 2 will execute. Let's see the output. So which thread will execute first? Which thread?
thread 1.
Thread 1. Thread 1 having which priority?
Normal.
Normal.
Normal priority.
then which thread execute?
3.
Thread 3, then thread 2, then thread 3. So let me run this application once more. Every time you run the application, you will get a different output. So in this case, you can see 1, then 2, then 3. So in this case, at thread 3, we are setting the highest priority, but that thread is going to be executed last or first.
Last.
So simply speaking, this thread priority concept is useless, right? Our assumption that we are setting this priority means it is going to be respect and this thread is going to be executed first, but in this case, we are getting a different output. So simply speaking, thread priority means it is useless. Even though we are setting the priority, it is not taken into consideration by the operating system. The output is unpredictable because threads are highly system dependent. Thread scheduler of the operating system schedule threads with no guarantee, but trying to consider them. For long running tasks, threads get the benefit of priority setting, right? So if you are running some task like long running task, right? In that case, you might get a benefit of using thread scheduling, but you cannot predict or there is no guarantee that what you are setting that you will get in the output. Then why do we need thread priority in C#? Well, this is not required in common sense, right? However, in some cases, when you want to elevate the priority of some thread, one such example could be when you want certain tasks to be completed fast over other. But if you want that one of the tasks to be completed before other tasks, then you need to use thread priority. But as we can see in the output, this is useless. You cannot predict, you cannot give guarantee that whatever you are setting, you will get the output, right? Some points to remember: a programmer can explicitly assign priority to a thread. You can see here, I'm explicitly assigning the priority to a thread, right? Then the next is the default value is thread priority dot normal, right? So in this case, if I'm not setting this thread priority, okay, in this case, I'm not setting, right? And when I run the application, then you will see that the thread priority is going to be normal also by default, right? Let me run this application. So what is the priority? Thread 1, it is normal, right? The operating system doesn't assign the priority to the threads, right? You are assigning the priority to the thread, but when your application is running, the operating does not assign that priority to the thread. And this is the reason why you can see you are unable to, you are not getting the output as per your expectation. Give me 1 minute. Right? And you can see it will throw thread state exception. Thread is dead, priority cannot be if the thread has reached a final state, right? So once you call the once the thread execution completed, and if you call the start method, then you will get this thread start exception, right? What we have already discussed this. It is not guaranteed that the thread whose priority is high will execute first and the thread whose priority is low will execute after, right? Due to context switching, the highest priority thread may execute after the lowest priority thread. So simply speaking, this thread priority is useless for me, right? So there is no use of setting the highest and the lowest priority. Any question from anyone related to this thread priorities?
I mean, it's not usable, I think so, no? Thread thing. I mean, it is not working. It is random output we will get.
Yes, it is not working because we are setting the priority for the operating system. will not assign those priorities to the thread. If operating system not assigning those priority to the thread, then how that thread is going to be executed first? It's simply decided by the operating system and the thread scheduler, right? They will choose which thread to be executed first and which thread to be executed last, right? So in our example, you can see we are setting the priority, but these priority are not taken care by the or not respected by the operating system.
Can I ask question from different from, I mean, thread priority topics? I mean, like a simplification question, like we use BODMAS rule. How we solve, we can't use the scenario priorities in that case. It is not working now, that also.
Sorry?
In math question simplification, BODMAS rule we use na priority plus
No,
or
Binary operation. Binary
that,
operation.
that Bournemouth rule, what you are using, right?
Yeah.
That basically used to evaluate an expression. The same rule is also applicable here, right? Suppose you are doing some mathematical calculations, right? Then in that case, that rule, what you are using in mathematics, that will also come into the picture, right? Okay, for example, right? Suppose you are having one double variable. Okay, let me do some long sum variable, right? X, right? So what I'm doing here, I'm writing 10 into
18 into 2 plus 4
okay,
something expression.
okay, 18 into, so you just tell me 18 into 2 plus 4, right? Minus 20 like this, right? So
Yeah.
okay, divided by 2. So
Yeah.
in this case, the same principle is applicable, right? In this case, you will see that the this operation will perform first, then this operation will perform, right? So in this case, 18 into 2, what will be the value? 36,
36.
right? 36. 36 plus 4, right? Minus 36 plus 4, right? Then minus 20 divided by 2, what will be the output?
10.
10. So in this case, the output is going to be 30. Right? So let me run this. The same is applicable here, right? It is no different, but this is a different thing, and the thread priorities is altogether a different thing.
Okay.
Right?
Yeah, fine.
It should give us 30. See, you can see we are getting the output as a 30. Okay. So the same principle is applicable to here also.
It is just showing, I'm following the BODMAS principle, that's all.
Yeah.
No priority as such is seen.
There is no priority. It's just an expression. It's just following the Botman's rule, right? Whichever operator having the highest priority, that operator will execute.
Okay.
In this case, this is okay. So in this case, if I'm putting this one, right? If I'm putting this bracket, right? So in this case, the bracket is having the highest priority. Okay. So guys, tell me what will be the output of this expression.
Okay. I'll check.
So do the calculation by yourself.
44. 44.
So one person is saying 44. Any other output?
It's 108 minus 20.
98.
98. Anything? First of all, see, in this case, this will be executed first. So what will be the expression like this in this case? 18 into 6, right? 18 into 6 minus 10. And this is 18 into,
Yeah.
right?
Yeah.
So in this case, the output should be 98, right? Now let's run the application. See, we are getting the output as a 98. So the same rule is applicable here, but that is the different story, and this thread priority is a different story.
Okay. Okay. Understand. Yeah.
So
Fine.
any question from anyone related to this thread priority?
I think so. It's not working. So it is not
It's useless.
real
I'm
time.
saying that. It's useless. But the thing is that if you are working with the SQL Server databases, right? At that time, thread priorities play important role, right? So if you are setting the priority of a thread, then that will be important.
Any practical example? I mean, basic.
Yeah. Suppose two threads are there, and I mean, two transactions are there. You want to make one transaction to be failed while others should be proceeded, right? Others should be successful, right? So in situations like this priority is important, right? So if you are working with if you are having experience of a SQL server, then you might know that. So that is out of the context, right? We are not going to discuss that, right? So you just do by yourself how you can do this. Right? Right. So you can go to the SQL server, right? In my SQL server, you can see there are many things I have written, and at some content article I have. Give me 1 minute, guys.
Okay.
So you just go and check how you can do this and how you can resolve this, right? Because it is a part of a SQL server, and we are not going to discuss anything related to SQL server, right? How you can set the priority, right? All these things that is covered in my SQL server course, right? You can see here, you can set the deadlock priority as normal, right? You can see low, normal, and high, right? In this case, transaction 1, this is transaction 2 code, right? And in this case, there is some deadlock, right? If you want to handle this deadlock, then you need to set the deadlock priority. So you are setting this transaction priority as high. High means this transaction is going to be written as the victim transaction. If this transaction is going to be stopped, and this transaction is going to be successful, right? So this is part of our SQL server, right? So what I could suggest is you just go to this link and check the concept, how the priority is work in deadlock. I mean, how the priority is work in SQL server, right? That is a different story altogether. But coming to our point, from the C# point of view, this is useless, and we should not keep more time on setting the priority of a thread.
Okay,
Clear?
sir. Yeah, clear.
Now, the next or the last important thing that what we are going to discuss is the performance benchmark between our single-threaded application and multi-threaded application, right? Right. So what we are going to discuss, I'm going to develop one single core processor application. See, first of all, we need to understand what is single core processor versus multi-core processor. See, suppose you are developing one multi-threaded application, right? You are developing one multi-threaded application, but in that multi-threaded application, you are only having a single core or single processor. And you are having a multi-core and a multi-processor, right? Multi-core processor. Then if you are running a multi-threaded application on a single core processor versus you are running a multi-threaded application in a multi-core processor, then what is the difference which is going to give you better performance? That is what we need to understand. Clear?
Yes.
Right. So first of all, we need to understand how many processors and cores are installed on my machine, whether it is a single core processor or it is a multi-core processor. So how you can verify? There are many options. So first option is go to task manager. right? Go to performance tab, select the CPU, and you can see the number of logical processors are there. That means 8 logical processor means what? Now, so in this case, 8 different threads can execute parallel, right? The number of logical processor it 8 means 8 different threads can execute parallel. If the number of logical processor or you are having a single core means what? Only one thread can execute at the same time, right? Parallelly, you cannot execute multiple thread because if you do not have multi-core processor. So in this case, I'm having multi-core 4-core, and you can see 8 logical processors. So 8 logical processor means 8 threads can execute parallelly at the same time, right? So, and if you want to check other way, so what you can do, so open the run window, right? Open the run window and just type ms info 32, right? ms info 32. Click on the OK button, and somewhere you will see the processor details. So you can see this is my processor details, the 8 logical processors, right? This is another option to know how many processors are installed on my machine. Another option is by using the processor count property, right? Processor count property. So by using this environment, that processor count, you can also get to know the number of processors installed on your machine or available on your machine. So in this case, it should give me the output as 8. So you can see the output, it is providing me 8. That means 8 logical processors are installed on my machine, right? Even you can also use this number of processors command in the command prompt to know the number of processors available on your machine. So copy this command, equal number of processors, and enter. So you can see it is giving me 8. That means 8 number of processors are available on my machine. So performance testing with multiple processors. See, if you have a machine with multiple processors, then multiple threads can execute your application code in parallel on different cores. So multiple threads can execute your application code parallel in different code, right? So, so number of core is 8. Number of core is 8 means each thread, right? One thread in each core is going to execute in parallel. That means 8 threads in 8 different core can execute your application code in the same time or in parallel. Is that clear? If you are having 2 core, 2 logical processors are there on your machine, then the maximum 2 threads can execute your application code in parallel. Why? Because 2 cores are there, one thread in one core, another thread in another core. 2 core means maximum 2 threads can execute your application code in parallel. If your machine having 4 cores, I mean 4 logical cores, then maximum 4 threads, right, can execute your application code in parallel, right? So that is what you need to remember. Is that clear? How the operating system and how these threads are going to be executed in parallel. If your machine having a single thread means what? Single core. Single core means what? Only one thread can going to execute your application code. If you are having multiple core means multiple thread can execute your application code. But the point that you need to remember is, so each thread is going to run on a different core, right? Suppose your application having 8 core processor means what? Means 8 different thread, they can execute your application code parallelly. One thread in one core, another thread in another core, another thread in another core. Like this way, different thread can execute your application code parallelly, right? If you have 4 threads, right, and if each thread takes 10 milliseconds to complete the execution, then on a machine with 4 processor, hold on, give me 1 minute, guys. Actually, my daughter is disturbing me. Okay, fine. So the point that you need to remember, if you have 4 threads and each thread takes 10 milliseconds to complete the execution, then on a machine with 4 processors, the total time taken is going to be 10 milliseconds. Why? Because 4 threads are there, 4 core are there, each thread is going to run on a different core. So 4 core available. So 4 threads are going to be run in parallel. So the execution is completed in 10 seconds. In the same time, if you are having 4 threads, but your machine having a single core, then at that time, the execution will not take place parallelly. So each thread is going to be executed sequentially. So in that scenario, your application execution, right, is going to take 40 milliseconds. Is that clear? Guys?
Yes.
Yeah,
Yes.
yeah, but let me ask you something. Maybe you already explained this, but I want to be sure. What happens with all the other things that the computer is doing? I mean,
See,
the
so in
computer
this
could be
case,
doing a lot of things.
see, in
What
this
happens
case,
with that?
see, in this case, what I'm taking is I'm assuming one thread is going to take 10 milliseconds. So 4 cores means 10 milli, but apart from that, other things are also going to take consideration. For other things, again, there is some time is going to be allocated, right? So the context switching, some IO resources is required, waiting time, right? So all these things are going to be taken care into consideration, right? So we are just assuming. Assuming means only we are taking the time into consideration, but other thing, right? Other thing also coming into the picture, but this is just for assumption, right? So you can say I'm having 2 different function. One is even number sum and another is odd number sum. So, and I'm having a big for loop which is executing for this number of time, right? And this odd number, it is also executing this number of time, and each time it is going to do the sum of all odd number, and this method is going to do the sum for all even numbers and finally print the ratio. But in this case, as my machine, okay, in this case, as my machine having, right, as my machine having multiple cores, so I cannot use multi-threading to show you the example of single core processor. So what I am doing, I'm not creating a multi-threaded application, rather I'm creating a single threaded application. A single threaded application is equivalent to multi-threaded application with one processor. So this is the point that you need to remember. What is the point? The point is single threaded application is equals to multi-threaded application with single processor. So clear this point, single threaded application is equivalent to multi-threaded application with single processor. So in my machine, as I have installed multiple processors, so I cannot show you the example, this one, multi-threaded application with single processor. So what I can show you the example using single threaded application. Then I will show you example of multi-threaded application using multiple processor. So the next example, a multi-threaded application with multiple processor. Is that clear what I'm trying to do? I cannot show you this one because already my system, they are having multiple processor. But instead of this, what I can show you this one because both are going to be same. Multi-threaded application with single processor means only one thread is going to do the task. Once that task execution completed, then other thread will come into the picture. But in this case, multi-threaded means if your processor, if you do not have multiple processor, then it doesn't make any sense to develop and run multi-threaded application. Multi-threaded application, if you are developing, then you must have multiple processor installed on your machine or on the server, right? And let me show you this example first using single threaded. So in this case, this is going to be a single threaded application because the main thread is going to execute the main thread, main method. The same main thread is executing this method, and the same main thread is going to execute this method. So in this case, this execution will be done fast. Once that execution completed, this method execution will be done, right? And here I'm using stopwatch, right? Stopwatch to show how many milliseconds this method took to complete the both the how many milliseconds the single threaded application took to complete this two method execution. Right now, let me run the application. See, it is taking 515 milliseconds, right? So in my machine, I'm having 8 core, right? So it doesn't matter it is a single core or a multi-core, right? So you can see in my machine, it is taking 515 milliseconds, right? Now let me do the same example using multi-threaded application and see how much time it is going to take to complete the execution. So the same odd number method, the same even number method, but in this case, instead of calling these two methods by using the main thread, I'm creating two different thread. One is thread 1, which is calling, which is going to execute this even number method, and this is thread 2, which is going to execute this odd number sum method. Then I'm starting this two thread execution. I'm calling the join method on both the thread instances to wait the main thread till the child thread complete its execution. Once the child thread execution is completed, I'm just printing the time taken by these two threads, right, to complete the program execution, right? Okay, let me run the application. So previously we got 515. Now I'm getting 338. But guys, one more thing that you need to remember, in my machine, I'm having 8 core processor, right? And if your machine, if you are installing, right, 4 core or 2 core, right, if the number of core is less on your machine, then sometimes you will see that this time is going to be more than the single thread application, right? Sometimes this time is going to be more than the single thread application, because if you are thinking that I'm using multi-threaded application and I'm going to get better performance, but the behind the scene to use the multi-threaded application, first of all, the thread object need to be created, right? Thread object is going to the ready state. From the ready state, it is moving to the runnable state, right? So all these things are, I mean, all these things are going on behind the scene, and which is also going to take some time. Apart from this context switching is there, right, from one thread to another thread, and all these things are happening behind the scene, right? If you are performing a small operation, right, if you are performing some small operation, then instead of using multi-threaded application, you can use single threaded application, which might be give you better performance, right? And if your operating system doesn't have multiple processors, like more number of processors, having only one processor or two core, right? Then in that scenario also, you will see that sometimes the multi-threaded application will give you less performance, right? So always try to compare the time, right? So try to do the same application using single thread, do the same application using multi-thread, and then compare which is going to give you better performance. And accordingly, you need to decide whether you need to go for multi-threaded application or whether you need to go for single-threaded application. It should not be like that multi-thread concept is available, I can blindly use, right? If using the multi-threaded application degrade your application performance, then what is the meaning of using that? So before using any concept, right, for the performance point of view, first of all, you need to do the R&D by yourself, right? First of all, you need to identify whether the multi-threaded application is really giving me better performance or not. If it is not giving, then why should I use? Understand my points, guys?
Yes. Yeah.
Right. So okay, let me do one thing. Suppose so see, in this case, I'm just removing the numbers, right? Okay, let's try to do that thing, whether check whether it is going to give you better performance or not. So 1, 2, 3, 4, 5, 6. Three, 4, 5, 6. One, 2, 3, 4, 5, 6. Right. So in this case, 151 milliseconds, right? 151 milliseconds it is taking. Now let's directly run this method 6 times and see how much time it is taking using a single thread application. Calling for the first time, second time, third time, fourth time, fifth time, sixth time, right? Let me run this application and see how much time it is taking. How much time it is taking? 0. Means what? Within milliseconds, the execution is going to be completed. So in this case, right? So in this case, if I'm using the multi-threaded application, which is taking approximately 151 milliseconds, and when I'm using this single threaded, it is taking more time or less time?
This
Less
time.
time.
Less time. So multi-threading concept is available. That doesn't mean you should use it blindly. First of all, you need to check whether the method is going to be a time-taking method or a smaller one. If it is a time-taking method, then only you need to consider using multi-threading, right? And then also you need to do a R&D. R&D in the sense, try to execute the method using multi-threaded, right, the multiple threads, and try to execute using a single thread, and you then see which one is taking more time, whether the multi-threaded or single thread application. Which one is giving you better performance? Go with that approach. But blindly don't go with the multi-threaded application. Clear?
Yes.
Okay, so why I'm saying this? Because I see many of the beginners level developer who are working, right? They know, they understand one concept, right? They blindly use that concept in the project. It should not be the case like that, right? Suppose someone understand one design pattern. They blindly use the design pattern in the project, even though the design pattern is not required for that particular scenario or particular cases. If it is required, then use. If it is not required, then why should you use? In this example, you can achieve the same output, right, using both the single thread application and using multi-thread application. So if you know the multi-threading concept, that I can create a thread class instance like this, I can call the start method, I can right, so I can make this method join method, then the method execution is going to complete. You know this concept and you can use this one, no one can stop you. But do it really required to use this concept? No, this is not required. I can achieve the same thing directly using this concept, right? Single threaded application, which is, gives me better performance. If it is giving me better performance, then why should I am going with this approach? So in this case, you can see this is the creation of a thread instance. Behind the scene, one delegate is going to be there. Behind the scene, the delegate is going to invoke this method, right? All these things are happening behind the scene, and this thing is going to take some time. Creating the thread class object, creating the delegate instance, invoking the delegate method. If multiple thread, then context switching is there, right? All these things are happening behind the scene, which is also going to take some time or not. If the time or duration, if it is not a long running task, then it will give you negative performance if you are using multi-threaded application, right? Anybody having any question related to today's session, they can ask me now. Now it's time for question session discussion. We have 20 minutes. Guys,
I think so. It's fine, sir.
It's fine. Anyone else?
No question, sir.
Yeah, I have
No
some
question.
questions.
Okay.
So what are the real-time applications of these threading concepts? We know that when we do a lot of operations, we go for multi-threading, like when it is like huge number of requests.
So already we have discussed from the beginning now. If I'm not using multi-threading, then what is the problem I'm facing? If I'm using multi-threading, then how I can achieve better performance? See, the real-time scenario of using multi-threading is to improve your overall application performance, right? Suppose in this case, you can see in our previous example, right? In this example, say real-time scenario means what? Multi-threading is basically used to improve your overall application performance, right? In this example, I have shown you the example using this multi-threading, right? And using a single thread application. And we have come to conclude that if I'm using multi-threading, it is taking less time if I'm using comparing with the single thread application. So basically multi-threading means to improve the application performance. There is no real-time example for multi-threading, right? It is just a concept to improve the application performance, right? So in this case, without multi-threading, you can achieve the same thing, right? Using a single thread application, you can perform the these two operations, right? But if I am using a single thread application, then how much time it is taking? If I am using multi-thread application, then how much time it is taking? That is what you need to understand. Multi-threading means basically used to improve the overall application performance. So overall application performance means what? It is going to execute the code. It is going to give you the output in less time compared with your single thread application.
Yeah, I mean, like my question was like, where and all you have used these concepts? Is it very often, or any specific scenario that you have used this in real time?
Did you attend our beginning sessions?
Yes, sir. I attended all the sessions.
So in that session, I have already shown you now if you are using multi-threading, right? And if you are not using the multi-threading, then what is the difference? All these things.
No, I actually, yes, sir. I know the difference. Like when we use multi-threading, we consume the less time. When we don't use it, is more time. And you recently explained that if we are going to use for very less usage, then it's better go for straight. But
right.
Real-time projects.
Real-time, see, suppose if you are developing one Windows application, right? So in that Windows application, if you are performing all the execution using a single thread, right? Once that thread execution starts, then the UI is going to be breached. You cannot do anything with your UI. But if you are using multi-threading, right? Once the execution started, other thread will continue their execution. So you will not feel that the UI is going to be frozen. So you can do other activity in the UI.
Because like with the projects that I've came across, I have not seen any threading concept till now. So I have seen async and await methods implemented in the projects, but
async await, what you are using behind the scene, this threading concept is there, right?
So
but until and unless you are not understanding the threading concept, right, you cannot understand async await, right? What is asynchronous programming? What is the difference between asynchronous programming and multi-threading? All these things you will, and I hope you are not using this multi-threading concept. This is because you might not work with any kind of a desktop application. You might be working with some web application or web APIs, right? If I'm not wrong. Right. So what kind of application you are working? Windows application, I mean desktop application or web application?
Web application.
Obviously, right? Web application means async await is there. But if you are working with the desktop application, then in that case you might be using this threading concept, right? Or if you are working with some kind of services, right? Services in the sense if you are developing some recharge application, right? Some recharge application means you are developing one application where you are taking doing the mobile recharge facility, where you are providing the mobile recharge facility. Some of the time you will see that some of the recharge operation successful and some of the recharge operation going into pending state, right? Whatever the pending operations, right, that you want to do you want to update the status in the background. For that, you need to develop some kind of a Windows services, right? In Windows services, you need to use this threading concept so that they can pick 100 records from the database, and they can simultaneously process those 100 records behind the scene, and again they are going to update the status of those records in the database. Have you ever worked with Windows services?
No.
Anyone working with any kind of Windows services? Right? Suppose, let me give you another example. Suppose you are working with you are working with the e-commerce application, right? Okay, I'm just asking you the question. You have to give me the solution. Suppose I'm buying some product from your website, and while I'm buying the product, while I'm going to make the payment, my payment is processed, right? But my system is shut down, and even you are calling the third-party payment gateway APIs, right? From that APIs, you are not getting the response, right? You understand my question? All the things order is placed, and while doing the payment, right? Your application take me to the payment APIs or payment gateway, right? And in that payment gateway, right, I process the payment. Money is deducted from my account, but due to some reason, your application doesn't get the response back from the payment gateway, right? Then in that scenario, how you will handle that case?
When I initiate the, when I initiate the payment, there, I think so, there is some platform where it initiation is going on.
Right.
And after that,
Yes.
okay, sorry, sir, you continue, sir. Sorry, sir. You
No,
continue.
I'm asking. This is a general question to all of you, not the one who is asking me the question, but this is a question to all of you. If this is the scenario, then how you will handle?
Okay.
Because you see, if you are going for the interview, right? If you are asking, I have worked on e-commerce application, then e-commerce application means this implementation is mandatory. E-commerce application without payment is not an e-commerce application. Right? If you are developing e-commerce application means payment gateway implementation is mandatory. But sometimes the payment is deducted from your bank account, but the application, the web application, what you developed is not getting response from the payment gateway or payment API. Then in that scenario, what you will do? In your database, the status is pending. From my account, the payment is deducted. Then what you will do? Any experienced developer who are working? Because see, don't think that if you are going for any experience interview, they are going to ask you what is inheritance, what is polymorphism, right? What is delegate? Don't expect these things. If you are having some experience, then definitely they will ask you question from your project. What kind of development you have done on your project, and how you handle the scenario. So in that case, what happens now? So to handle these scenarios, they are provided some kind of APIs, right? Those you need to develop one services, Windows services, right, which is going to run in the backend. In the sense, for that no UI is required, right? UI is not required. Every 10 minutes, every 5 minutes, or every 15 minutes, that exe, or you can say that Windows services or any services you develop, that is going to run. So what it will do, it will check the database, whether is there any record, any pending amount, any record which status is pending for the payment. Yes, some of the status is pending in the database. So take the record, hit the API, payment gateway API, right? Get the current status of the data, right? Current status of that particular record or particular payment, and then update the database. Right, that functionality, right? It might be possible that in your database 100,000 records are there in the pending state, And taking one by one record and doing the operation is going to be time consuming, right? Within 5 minutes, within 10 minutes, you might be seen that sometimes you are buying the product in Amazon, right? Some payment information not immediate update immediately, right? They're taking 5 minutes and 10 minutes, and then they are updating that the payment is successful or payment is failed. How they are implementing this? Behind the scene, they are implemented the logic like this. So in that scenario, you can use multi-thread. You can take multiple records from the database, process each record using a different thread, right? And get the output and update the data.
Means
Right.
database work is working in this scenario. I mean,
Obviously, you see, if you are developing any kind of application, if there is no database, then don't think that that is the application.
yeah.
Without a database, you can think if there is no database, right? Then what is the use of this programming language? Simply HTML, CSS, JavaScript. That's enough.
Yeah.
Right. Right. So many use cases are there, and what you are going to use that asynchronous programming, async await task, right? Parallel programming, all these things behind the scene, multi-threading concept is there. Right. The way, see, if you are using multi-threading, what is there behind the scene? Delegate is there or not? Yes or no? Suppose you are
Yes.
multi-threading, you are passing this event number function, and when you call this method thread, this method is going to be executed. How it is going to execute? Because this thread class taking one constructor, which is a delegate, and that delegate signature is same as this method signature. And behind the scene, that delegate instance is created, and that delegate instance is invoked. And when that delegate instance is invoked, that delegate pointing to what method, that method is going to be executed internally. Right. So similarly, that asynchronous programming, that parallel programming, right? So what you understand, what you learn in your project or from other things, right? So once we start asynchronous programming, definitely you will learn something new, right? Multi-threading is not mean ki just create the method and invoke the start, right? There are many things available in multi-threading, right? So if you look at this thing, so we have discussed multi-threading, thread class, how to pass data to a thread function in a type-set manner, how to retrieve data from a thread function in C#, is elif and join method, thread synchronization, lock, monitor, mutex, semaphore, sleep, right? Del log, thread pooling, for foreground, background, thread lifecycle, thread priorities, and performance testing. We have discussed this much. Apart from this, there are a few other things are also available. How to terminate a thread in C#. That is what we are going to discuss. Then we will discuss how to debug a multi-threaded application. As of now, see, in this case, you can see there are two methods, right? How I can debug this method. So I cannot predict which method is going to be executed first and what is the value. All these things in this case, you can simply predict. You cannot debug this application properly, right? So what you how you can debug this multi-threaded application, right? So currently this one is executing on I click, this one is executing. How why this is happening? I only want to debug this method. I don't want to debug this method. Is that possible? Yes, it is possible. How? That we will see tomorrow. Right? Many things is there. And coming to our asynchronous programming, right? Let me open the course syllabus. Right? So why I'm not going to mix up the things, because you will not understand. You will only get confused, right? So see, this is our asynchronous programming syllabus, right? What is asynchronous programming? Async and await operator in C#. See, what maximum you can see, this async and await operator. But apart from async and await operator, there is something called a task. How to return a value from a task, how to execute multiple tasks, how to limit the number of a concurrent task, right? How to cancel a task in C# using cancellation token, how to create a synchronous method using task. See, if you are using asynchronous programming or a task-based programming, then they are going to be execute asynchronous. Asynchronous means once execution continue, other thing will continue. But how you can make the asynchronous method to behave like asynchronous? What is a retry pattern, right? What is only one pattern, right? How to control the result of a task, task-based asynchronous programming, changing task, value task, how to cancel a non-cancelable task, asynchronous stream, how to cancel asynchronous stream, right? So all these things are available as part of a asynchronous, not only this async and await operator. And what maximum in other institution or other peoples and other, they are saying that asynchronous programming means async and await, declare the method using the async keyword, call the method by using the await keyword. And once you call the method, that method is going to be executed asynchronously, right? So this is not what about asynchronous programming. This is just only 10% of asynchronous programming. Apart from that, many things that you need to understand. How you can control the number of concurrent tasks to be executed at the same time. How you can cancel, and suppose you make one method, right? If you make one asynchronous call, that method execution is going on, and you want, if that method execution is not completed in 5 seconds, right? Or 200 milliseconds, if the method execution not completed, then cancel the execution. How you can do this? All these things we are going to discuss, right? Apart from async, this is the advanced version of asynchronous programming, and there is also called parallel programming. See, here also we are going to discuss what is parallel programming, what is the difference between asynchronous programming. While I'm discussing asynchronous programming, I will show you what is the difference between asynchronous programming and multi-threading. All these things we are going to cover, right? But before asynchronous and parallel programming, the next concept what we are going to discuss, we are not going to discuss this reflection and file handling. We are going to start collection framework, because this is very, very important, right? Collection framework. And in collection framework, again, there are different types of collection framework. First of all, we'll understand what is array, because array is the one which is available from our traditional programming languages like C, C++, Java. Then we'll understand what is collection. Collection means we'll understand non-generic collection. Then we'll understand generic collection, right? And then we'll understand the latest and new concurrent collection. So in each collection, there are a lot of classes. Built-in classes are provided by .NET framework. Each classes having lots of inbuilt methods, right? We try to understand, we'll understand each method of each classes, right? Whether it is generic, non-generic, concurrent, what is the advantages and disadvantages of array, why collection framework come into the picture, collection framework come into the picture, then why generic collection comes into the picture. I mean, there is some disadvantages of collection framework and how we can overcome those things using generic collection. Then why this concurrent collection come into the picture. All these things we are going to discuss. Clear? Right?
Yes, sir.
Yeah. So this is how we are going to plan, right? So any question from anyone?
No, sir.
Okay, fine. That's it for today. Again, we'll see tomorrow, same time, 6:30.
Thank you, sir.